Hey there, welcome to this exciting demo session on designing and implementing SD-WAN. And this is your instructor, Abhijit. You can call me AB if it's hard to pronounce for some of you guys. But I'm representing over here PyNet Labs Private Limited. And in this session, we're going to talk about the very fundamentals of actually why do we need SD-WAN. And as we are coming up with the exclusive trainings of SD-WAN that will kind of be demonstrated by taking the lab scenarios and real-time scenarios in consideration. So we thought of why not to come up with a demo session that would actually help you guys to understand what we are going to cover in this training and how would we be catering this particular training for all the participants that are going to join this training. So I hope this video will actually help you in order to understand what is SDM, why is there such a need in the industry about the SDM, as almost everyone is looking forward to implement SD-WAN in the production scenario. And then as we have something called SDN going on, so we'll talk about that in some time. So I, Abhijit, welcome you all to this demo session and I hope you'll enjoy the content of this particular session. Now, talking about myself, before we jump into directly the session, I represent PyNet Labs Private Limited, and I have been in the training and consultancy industry since last 8 years, and I've been delivering trainings to domestic as well as my international clients. And the key interest of myself has been about routing and switching, some part of security, data center technology, service provider networks. And then as Cisco came up with the new line of certification, I switched my interests deeply into the network automation. And then there I fell in love with software-defined networking, or you can say network automation. So SD-WAN is, you can say, a product of, or the children of, one of the children of SDN, and we're going to talk about what this SD-WAN solution of Cisco is. Okay, now in order to begin with, I'll firstly introduce you with the need of SD-WAN. Why is there so much of talks that are going on in the industry about SD-WAN, SD-WAN and SD-WAN? So when we look into this, then you actually get to know that the networks as of today are becoming so much of complex. Okay, the complexity is going beyond of its limits that some of the developers or some of the key people who designed internet dreamt of or thought of or assumed of. So if we look of a traditional network and how that particular networks actually look like, then usually we do use different network devices in our network, because if you want to come up with something, you can say a local area network, then you can say a local area network can be thought of something like you have multiple devices, you have different PCs, and then you have some centralized device in order to manage that network. Let's say you have a switch, and that switch actually connects all these devices together, and then that kind of becomes something called local area network. And now if you have multiple local area networks like this, you have a LAN over here, you have a LAN over here, you have a LAN over here, and all of these LANs actually can be connected together, okay, in a mesh fashion or in some other type of topology or so, then the network keeps on going bigger and bigger. And that's how our internet has been built up. So what we call as, when we connect multiple LANs together, then you call it as metropolitan area network. And when you connect multiple MANs together or multiple metropolitan area networks together, then you can say that it can be assumed of something like WAN. And WAN stands for Wide Area Network, which in today's world is nothing but our internet that we actually use. So our internet is a big WAN or wide area network, you can say. Okay, but this is not the scenario that WAN is something that actually can only become when you consider its size or its complexity or its scale or something else, right? WAN is WAN has been growing since the beginning of the internet, since internet came out into existence. And if we look at today's wide area network in comparison with the WAN that we actually had almost a decade ago or a couple of decades ago, then the WAN was not that complex at all. So as time is passing, the complexity of WAN is actually increasing in a compound fashion. Okay, if something is complex today, then tomorrow it's double the complex. It's double in the terms of complexity as of today. Okay, now in order to look into what traditional networks or how traditional networks actually were functioning, then as I told you that you can come up with local area networks, you can come up with metropolitan area networks or wide area networks. These networks can be brought into existence when you actually take help of different networking devices. So you can say you're using something like routers, you're using something like switches, you're using something like firewalls, you're using something like load balancers, right? Or various other terms or various other devices inside your network to make it secure, to make it scalable, to make it, I would say, with redundant or capable of providing high availability and whatnot. Okay, there are so many factors that a network needs to consider or a network admin needs to consider before deploying its wide area network. Now, when we look at the terms of all these devices that we actually use, these devices are configured or these devices are manufactured by different vendors. Okay, so you can say we have the biggest manufacturer in the world of networking devices, Cisco, and then you have something called Juniper as well. You have companies like Ciena as well. You have companies like Huawei as well, right? And so many others as well. Palo Alto and Fortinet and FortiGate. Every company almost creates some or the other type of network devices that deals in networking. Okay. Now, if I took some or if I take a couple of devices of certain vendor, and when I connect that particular device into my network, then I have to configure it. Okay, now let's say that I take a router, and this is basically a router that actually is manufactured by Cisco. Now, in order to, I would say, manage this particular router, what I need to do, I need to actually get a connection or get a PC or a computer, and I need to connect with that particular device by using something called console cable. People who are actually dealing into networking industry might be able to relate with me. So you guys use a console cable in order to get connected with that particular device, and you access something called CLI, and CLI stands for command line interface. And by using this CLI, you actually configure multiple devices. Okay, so if you have a router there, then if you have a switch there, then if you have a firewall there, and then if you have a load balancer there, and so many other appliances, then with each appliance, irrespective of which manufacturer or who's the manufacturer of that particular device, you need to get connected with that particular device individually and then configure it. Make sense? Now we call such type of configuration as one-by-one configuration, but that's not the only approach, or that's not the only thing that actually makes traditional networks that we have been using limited with the capacity that it has. What actually I want to say over here is, whenever you have such traditional networks, then each and every device, if we just, let's say, consider something called a firewall or an ASA or something like that, then in terms of a router, a networking device has different functionalities to cater the needs of the network. And you can say that, let's say, a router. So a router needs to do certain tasks when it is being deployed into the production environment. First task, you can say that it needs to find out, you can say, best path or best route for the destination network. Because when you have a scenario like this, that you have a router, then you have a switch, and then you have multiple users connected, and this router is actually connected with something called WAN or something called internet. And when these people wants to reach out over here into internet, then the router is going to help that particular network or help the users reach out to the wide area network. So when I explain that, I actually mean that whenever there is some traffic that reaches out to the router, then that router actually needs to figure out the best way possible in order to make that particular device or user reach out to the destination as soon as possible. Okay, now all of these tasks that a router actually needs to do with the networking device needs to be done in a way that it will be catered out in some or the other fashion. So when we actually look at over here, then a router has different planes there, and you can say that the router's responsibilities are divided into different, you can say, planes. Yeah, so when I talk about this particular router making the traffic that it's receiving reach out to the destination network in the internet, no matter, like, every particular device might be in the need of getting connected with the internet on some or the other resource that is present. Internet is vast, right? So in order to make all of these users requests fulfilled, the router has to do certain tasks, and as I told you, one of the tasks can be to find out the best path for the device actually to reach out to the destination. And when I say that, I actually mean that these different tasks that every device does are divided into certain planes. So a networking device usually has 3 planes. You can say the first plane can be thought of something called management plane. The second plane can be thought of something called control plane. And the third plane can actually be thought of something called data plane. Now when we talk about these management plane, control plane and data plane, management plane actually is something that lets you get connected with the device, just like I demonstrated over here, right? So a router is there and a management PC is there, and it's actually grabbing the console of that. Otherwise, the user can actually be situated somewhere else. Let's say this is your WAN network, and then that's the user connected. So the user can actually be connected with that device by using management protocols like SSH, and he can grab, or he or she can grab, the access of the command line interface of the device by using SSH, by using remote protocols, right? So management plane lets you get connected with that particular device, and then the plane actually lets you access the device's command line interfaces or any other medium, be it graphical user interface or anything else, and provision the device configuration there. However, if we talk about control plane is actually the key element of a networking devices. And if we talk about a router, then the router gets able to take all the decisions that it needs to take with the help of the provisioning of control plane. So when we look at the control plane, I would kind of think of something. If we talk about control plane, then your control plane might look something like this. And let's assume that for a router, the best part that it can do in terms of performing the task is do routing. And routing can be done by various protocols that you can have. So you can have your router configured with something called OSPF. You can have your router configured with EIGRP, with BGP, and with certain other protocols that are available. So let's assume that if we talk about a control plane of a device, then the router has something called OSPF running up. And then you have something called EIGRP as well. And then you also have something called static routing that is working inside of that particular control plane. And if I look at OSPF and if I look at EIGRP, then both of these protocols, after executing the configuration, come up with or exchanges some information with the neighbors that you have. Might be your router, let's say this is your R1, the R1 is connected with R2, and then it's connected with R3, and then it's connected with R4. So this particular scenario would be called something as OSPF domain, right? And in this domain, these routers are going to be neighbors with each other. So when they exchange information, the information is actually stored somewhere. And we call this storage as different tables, or the storage of this information is done with the help of different tables. Okay, so if we talk about I would say OSPF. Then OSPF maintains multiple tables over there. Okay, and if I consider the tables that are done by OSPF and EIGRP, then OSPF is going to create something called neighbor table, and it will also create something called database table. Okay, and in neighbor table it will keep the information that it's neighbor with, and in database table is going to keep the information of all the routes that has been received from its neighbor. And then if we talk about EIGRP, then EIGRP is something called also maintains some tables called neighbor table, and it also maintains something called topology table, which is equivalent to the database table of the OSPF. And it keeps all the information about the routes that it has received from the neighbors inside of that topology table. And then it also builds something which is the most important element of a router, which is called RIB, which stands for routing information base, or you can also call it as a routing table. And the best path from this database table or this neighbor table is actually placed into the routing information base. And this is kind of the brain of that particular router, upon or based on which it gets able to take the decision of where to forward the traffic or not. So when you look at that, then static routing doesn't actually creates any tables or so, and it directly injects the route into the routing table. Now when your routing table is ready, this is not actually according to what the data is forwarded. There is a separate plane for inside the network device to forward the traffic, which is actually called as something called data plane. So when you look at the data plane, then data plane contains something you can call as FIB, which stands for forwarding information base. And forwarding information base is just the exact copy of routing information base. And whenever any traffic comes up, because forwarding information base maintains the information about all the interfaces that the device has and every other configuration that's there. So you can say whenever a traffic comes inside, then the router actually checks into the FIB for the information that it has, because it's going to have source IP address, the destination IP address, and all the other parameters that is being collected from the originator of the traffic. So when you have source IP and destination IP and all these things, this information is actually compared with the forwarding information base. And then based on the information that you have, the router takes the decision on which interface does traffic actually needs to be forwarded. Maybe you are getting an incoming frames on incoming packets on FA0/0, and then you want to forward it out on FA0/1. But on what interface does it needs to forward it? It will completely depend on the information that the router contains inside of a data plane. So data plane is something that actually cannot be provisioned manually, or that cannot be configured manually. But control plane is something that a user or that a network admin provisions. Make sense? Now this is actually how the router makes decision. Okay, now if I consider a scenario, let's say that, but like based on this information, let's say that you have multiple branches. You have a headquarter here, and the headquarter, or you can let's build up a scenario like this. So you have, for example, an R1, and then you have an R2, and both of these routers are the edge routers, okay, of the headquarter. And then this R1 and R2 is connected to something called the internet via the service provider. And then if you look at there is another branch that has R3, okay, and this is a branch that is situated, let's say, in Dubai, and your headquarter is situated into, let's say, New Delhi. And you guys are connected with the help of, like, both of these branches are connected with the help of wide area network. Now this R1 and R2 also has some security parameters implemented. Let's say you have a firewall here and you have a firewall over here as well, and you are connected with that particular firewall in a mesh fashion. And then you also have some layer 3 switches, L3 switch 1, and then you have L3 switch 2 that are taking care of the aggregation, okay, which means like forwarding or doing all type of layer 2 layer 3 things. And then these L3 devices are also connected in the mesh fashion, and then you finally have some distribution layer switches like L2, and you can say L2 is over here as well, okay. And then you have something, let's say in a data center environment you would have VMware ESXi server, and on that ESXi there are multiple virtual machines that are being shifted, and this ESXi is connected with that switch. Now there are users that are connected in this particular branch, which actually works for your organization and the company, and all these users needs to access the applications that are being hosted onto this virtual machine server. Now you assume to have some such kind of deployment in your network, you might need to do configuration on multiple devices, and like all these router needs to be created, okay. And you can say that when you create these routers, then you can actually say that routing needs to be implemented, subnetting needs to be done, you can say access control list needs to be created, filtering needs to be done, network address translation, and so many other type of configuration actually needs to be done. Now, as I told you previously, that every device has control plane, every device has its data plane, and every device has its management plane. So for a network admin to configure all these devices, it will actually be it will actually need to get connected or like reach out to all the devices that you have in this scenario and configure it one by one. Make sense? And let's say in future there is additional virtual machines that are created inside the same ESXi server, and then the same user needs to be provided the access of this application. Then again you will need to provide a bunch of time in order to make that particular change live in your network. And because every device maintains its control plane and data plane locally, you need to go on each and every device that's going to be there and configure it individually. So this type of approach is called as traditional approach, and it is very manual approach, and it is very slow approach, which is basically the limitation of today's world. Okay, so that is why whenever we talk about something called SDN, software defined networking, in software defined networking you have actually the ability to centralize the control plane of your device. And when you centralize the control plane of your device, you can actually connect with the entire fabric from a central point of touch. So you can say that the entire section over here can actually be managed from a single management PC by getting over to the SDN controller and provisioning all the devices that you have with one go. And this is something that we call as software defined networking. Okay, this is something that we call as centralized infrastructure. Okay, and not the distributed infrastructure like we just discussed. So SDN actually has two children's, majorly talking about. One of its children is called as SD Access, which takes care of managing all the local and enterprise network. And the other children that it has is SD-WAN, which actually takes care of provisioning all the wide area network with the centralized I would say system, where you will get the control plane access from a centralized view, and you will be able to configure all the edge devices of all your branches from the centralized infrastructure. Makes sense? Now there are different, this is something that we actually called as SDN and its products. And the thing that I explained to you, that why do we actually need it, because the traditional method is very manual and the traditional network is very slow in terms of deployment and looking at the complexity that we actually have here. So what we are going to look into this particular training is the Cisco's SD-WAN solution, because there are so many vendors that are available, and you can say that almost every vendor has its own SD-WAN solution as well. But when we look at Cisco's SD-WAN solution, then this is actually going to be the course outline, because the course is going to be about almost 45 hours. Okay, we're coming up with the 45 hours of training, and this particular training is going to focus on the complete theory plus we will have the lab deployment of SD-WAN and how labs can actually be configured. Okay, so in which we're going to talk about architecture, which means what's the SD-WAN architecture. We're going to talk about the controller deployment, because SD-WAN solution of Cisco offers various controllers. You have vManage, you have vBond, you have vSmart, and you have vEdge. So we're going to talk about all the controllers that you're gonna get inside the SD-WAN solution of Cisco, and then we will see what each and every controller actually does for the SD-WAN solution and how it simplifies the tasks for you for managing your WAN infrastructure. And then we're going to talk about router deployment as well. We're going to see how the edge devices, how the branch routers that can actually be connected with multiple branch deployments over there. And then we will see how policies can be configured in terms of be it routing policies, security policies, be it quality of service, how traffic actually needs to be specified over there, and how all the BGP, OSPF and overlay protocols and underlay protocols that are going to play a role inside of this SD-WAN fabric. And then we are going to focus on management and operations of this SD-WAN solution. So we're going to see how you actually perform day-to-day operations by using these controllers. We're going to see how you manage your entire WAN infrastructure and its operations with the help of all the controllers that you have in this scenario. If I look at the content is actually figured out, or the content that we are going to cover in this training is going to be the same content according to the official Cisco's SD-WAN training. So you can look over there into the official Cisco's website, and the content is actually same. So if you are planning up for the certification as well or the global exam as well, we're going to cover the same content that would actually help you to prepare for the examination as well. And as I mentioned, that the course is not only going to be theory, but it's also going to be provided with the hands-on lab. So each one of the candidate that's going to participate in this particular training is going to get the hands-on lab experience. And if I talk about some of the you can say lab overview, then you can see this is how a normal lab overview looks like. You might have this as one of the branch, you might have this as some other branch, and then you have multiple service providers that actually is connecting your branch offices with the headquarters that you have, or the data center environment that you have. And in the data center, you will have all the controllers that are deployed, be it vBond, vManage, vSmart, or vEdge. Basically, vEdges are something that gets deployed on every branch. But yeah, in the headquarters, you're going to have all the controllers set up, and from there, you can manage all the branches that you have by using overlay routing, by using underlay routing, but we'll be talking about that in much detail over there. So we are going to come up with how the topology can actually be built up, and we're going to start from the scratch when it comes to the lab. So you won't be given with a ready-made topology there, because you yourself will be able to bring or build your own topology of your WAN deployment, and then we will see how you can actually connect multiple sites together in the SD-WAN solution of that. So I hope this demo session kind of helps you in order to understand what is SD-WAN and why there is any need in the industry for this SD-WAN solution, and then how we are going to cater this particular training along with the content and the lab for you guys. So thank you so much for watching this particular demo session. I hope you enjoyed the content of this session, and I'm looking forward to see you on board on our training.